Hello friends, welcome to our channel Engineering and Technology for You. In today's video, you will learn 8086 physical address and memory segmentation. Let us start with the addressing capacity. 8086 has a 20-bit address bus and can access up to 2 raised to 20 memory locations. So 2 raised to 20 is nothing but 1048576 or 1 MB memory locations. Thus, memory space of 8086 can be thought of as consisting of 1048576 bytes or 524288 words. Words are nothing but 16-bit. So, the number of words will be half of the bytes. Then 8086 can access memory with address ranging from 0000H to FFFFH. So this is the total range for 1 MB memory. Then memory is divided into 16 blocks, each of 64 KB. These blocks are called segments. Let us see the memory map of 8086. So as you can see here, the memory map consists of, here the starting address is 0000H and the last address is FFFFH. Then we have the 16 segments, segment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Then each segment has capacity of 64 KB. This is shown here. You can see the first segment is 0000H to 0FFFH. So this total space is 64 KB. Then from 00000H to FFFFH, the total memory space is 1 MB or 1048576 bytes. So this is the actual physical memory of 8086. Then let us go further and see what is memory segmentation. Now segmentation provides a powerful memory management mechanism. As we have already seen, 1 MB memory of 8086 is partitioned or segmented into 16 segments. Each segment is of 64 KB length, kilobytes length. That is 2 raised to 16, that is 64 kilobytes. Out of these 16 segments, only 4 segments can be active at any given instant of time. So as you'll see that these segments are core segment, stack segment, data segment and extra segment. These 4 segments that CPU works with at any time are called currently active segments. And corresponding to these 4 segments, there are 4 registers. First is the core segment register, then data segment register, then stack segment register, then extra segment register. So because of these 4 segment registers, there can be only 4 segments active at any given time. So let us understand what is segmented addressing. Segmented addressing uses 2 components to specify a memory location. First is the segment value and the other is the offset within that segment. So that is the 2 components for specifying a memory locations. So as you can see here in this figure, these are the segments, 4 segments which are active. This is the core segment, data segment, stack segment and extra segment. So corresponding to these registers, we have the particular segment shown here. So these are the registers which are 16-bit. CS, that is stack segment, is the register, and here we have the memory which is called as the code segment. Then for data segment register, we have the data segment memory. Then for stack segment, we have the stack segment memory, and for extra segment, we have the extra segment memory. So this all will correspond to linear memory space of 1 MB. So the total space of 1 MB is divided into segments, and at any time only 4 segments will be active, that is core segment, data segment, stack segment and extra segment. So this is what is the segmentation of memory in 8086. Let us see the use of segments. Now each of these 4 registers are 16-bit wide and they are user accessible. That means user can change the values with the help of program. Then code segment contains the instruction codes of the program. So this is important point. It contains the instruction codes of the program. Then the data segment contains the data variables and constants. Then the stack segment is used to store interrupts and subroutine return addresses. So generally it will be used in the stack operation. Then the extra segment contains the destination of data for certain string instructions. The 64 KB are available for program storage in code segment as well as for stack in stack segment, while 128 KB of space can be utilized for data storage in data segment and extra segment. So these are the basic use of different segments in 8086. Then let us see what is logical base segment and physical address. The logical address also goes by the name effective address or offset address, or sometimes it is also called as the offset. It is contained in the 16-bit instruction pointer, then base pointer, stack pointer, base register and the source index or DR, destination index. The 16-bit contents of one of the 4 segments registers, that is CS, DS, ES, SS, is known as the base segment address. Then offset and base segment addresses are combined to form a 20-bit physical address, also called real address, that is used to access the memory. This 20-bit address is put on the address bus AD19 to AD0 by the BIU or bus interface unit. We have discussed the architecture of 8086 in the first video on 8086. In that we have discussed the bus interface unit and execution unit in details. And in the second lecture we have discussed all the registers of 8086. So those who have not watched those videos, they can refer to those videos. Then let us see the generation of physical address. Here you can see in the figure we have effective address IP. Here we are considering the CS segment, that is the code segment. So the offset will be in the IP. So effective address or logical address is 16-bit. Then the segment register contents are 16-bit. These are appended with 4 bits at the lower side with zeros. So that will form the segment address, starting address of the segment. Then these two, logical address and the segment address, they are added in a 20-bit adder, which is part of the bus interface unit. So after addition we will get the 20-bit physical address of the memory. So it will be 20-bit. So this is how the address will be generated. Physical address will be generated. Let us see this with the help of steps. Now, first step is decide the memory segment to be accessed, whether it is code segment, data segment, stack segment or extra segment. Then second step, take the base segment address from the corresponding segment register. So the contents of the segment register, particular register, if you take CS code segment register, then contents of CS will be the base segment address. Then step 3, the bus interface unit will automatically insert zeros for the lowest 4 bits of the base segment to get 20-bit physical address for the starting of the segment. So that is the starting address of the segment, that will be 20-bit. Then step 4, add starting address of the segment to the offset to get 20-bit physical address of the memory location. So these are the general steps for calculation of physical address, and they are applicable to all the segments. There is code segment, data segment, stack segment and extra segment. Then let us take example here. Example, we are taking the obtain 20-bit physical address generated by BIU if the contents of CS, that is the code segment register, and IP are 1234H and 5432H respectively. So let us see the step by step. Now first step, decide the memory segment. So here the segment is CS, code segment. Then second step, the contents of CS 1234. So that will be the base segment address 1234. So I have taken in hexadecimal as well as in binary. Then step 3. Here we are inserting 4 zeros. You can see here 4 zeros are inserted for the lowest 4 bits. And if you take in hexadecimal a 0, you will find only single 0. So the starting address of the segment will be 12340. Then step 4, 12340 plus 5432. So that will give us the just binary addition, hexadecimal addition. If you do, it will be 1772H. So that will be the result. So that will be the actual physical address, which is 20-bit for the memory location. So here again, this is shown with the help of figure. Here segment starting address is given. So that is 1234H 1234, and then it is appended with 4 zeros. So 12340H. Then offset address IP, the contents of IP 5432. So we get, after addition, we get the 20-bit physical address. It is 17772, 1772H in hexadecimal. So this is how the 20-bit physical address will be generated. Then let us see the default use for memory addressing. So each of the segments, so they are having particular offset register. Say CS, code segment, always IP will be used as the offset register. No other register can be used along with CS. So it will find the address of the next instruction to be executed. Then SS, it will either use ESP or BP. The stack segment, so it will be the function is for addressing the stack. Then DS, data segment, it may use BX, base register, DI, destination index, source index, or a 16-bit number. So that is also possible. So that will address, that is address of the data. Then ES, it will use the DI as the offset register, and it is for the address of data in string instructions. So these are the default offset register along with the segment registers. Then let us take example of physical address calculation so that the things are clear for you. So here the contents of following registers of 8086, CS is 1000H, DS is 3000H, SS 2520H, and then IP is 1234H, SP is 1100H, DI is 0040H. Calculate the corresponding physical address for the address bytes in CS, DS and SS segments of 8086. So this is the example. Let us see the solution for this. Now first, CS is given as 1000H, IP is given as 1234H. So the offset address will be 1234H. Now for the base address of the core segment, it will be 1000. 10 is appended here. So CS multiplied by 10 hexadecimal or CS multiplied by 16 decimal. So that is shifting the contents of core segment by 4 bits or appending 0 to that. So the physical address of the memory is given by CS into 10H plus IP. So that will be 1000H plus 1234H. So that gives us 11234H. So here, as we are using the core segment, default offset will be the IP. Then the second case, data segment. The address is 3000H and DI it is 0040H. So the offset address is 0040H. The base address of the data segment. So again we have to multiply it by 10H or 16D. So it will be 30000H. The physical address of the memory is given by DS into 10H plus DI. So it will be 30000 plus 0040H. So that is 30040H. Then last case, the stack segment 2520H and stack pointer is 1100H. So offset address will be 1100H. The base address of the stack segment will be 25200H. So just 1 0 we have to add here. Then physical address of the memory is given by SS into 10H plus SP. So that is what this 52000 plus 1200. So that will give us 26300H. So this is how we can calculate the physical address. I hope you have understood the calculation of physical address and other things which are I have discussed here today. So if you have liked the video, please press the like button and share with your friends and subscribe to our channel Engineering and Technology for You. I will be uploading more videos on 8086, 8051 and 8081. For any questions, you can find me on Twitter @ugokhale and email ulhaskumargokhale@gmail.com and Instagram @Gokhale Ulhaskumar. So thanks for watching. Thank you.
I have you now.